Hello and welcome. I'm Bill Wake. We're here working on parser combinators in Swift, and we've come a long ways. We've got some important ones done. Whoops. Let's try that again. Okay. Anyway, we've come a long ways. We got some done, but I want to focus on packaging today. So we've built this as a separate library, and one of the mistakes I've made before is to go too long without actually trying the library out. Just go in and develop, and never try it. And I know the last time I did that, I found out there were some places I needed to make things public that I didn't make public and things like that. So I suspect the same thing will happen this time. It's not programming per se, but it's an important part of delivering a product. Now, I don't want to take it as far as we could. I just want to make sure we can build it, see it locally, and everything works the way it should. The real way, I need to set up the GitHub package and figure out how to distribute it and get a link and all that stuff. I just want to get the minimal version of packaging done now. Make sure it's an encapsulated thing that's got the right stuff public and so on. I don't think that'll take us all day, and we'll go back to Combinators, but I wanted to get that done before too long. It's part of the thing of making a whole end-to-end product. It's easy to put off the stuff that's not the programming. All right. So what we've done so far, we created this as a library. You can see there's a little icon here. It's kind of I don't know, it's a box with flaps maybe. And the one over here, this one's a normal project. It's got that, I don't know what they are, a little compass tool or something that part of the icon there. I guess 3 overlapping rulers, whatever. But this one's a project, and this one's a library or a package. I guess that's a package. And so when it's a package, it doesn't have this one has an Xcode project, and this one doesn't. It has this package.swift. It's got a Swift tool version, so it knows how to interpret it. It tells us we have a package pcombo, and targets. We have pcombo and pcombo tests, which depends on pcombo. It's pretty minimal. If we had other dependencies, they'd be listed here and so on. And basically, you have a common structure for libraries. At the top, you have the README in the package, then a sources folder with individual package things in it, and same for tests. And sort of this pattern of how you lay things out is what makes all this work. Okay. And I have an article. All right. So organizing your code with local packages. Well, that sounds like what we want to do for now. We've identified code for modularization. We created a Swift local package in our second project there. Don't create a repository. We'll straighten that out later. Move your code in and do the package manifest. Okay, we developed it as a package, so that's done. Select your project in the project navigator. Select the local. Okay, so I think this is on us, on our project. Frameworks, libraries, and embedded content. Okay, so back to this one. Project info configuration package dependency sounds more like it. Does that seem select target? It's general pane. Well, I don't know what that means. Target general. Okay. Frameworks, libraries, and embedded content. Okay. So frameworks and libraries to add. Well, it's not this. Tests. Add other. Add package dependency. So we're just going to navigate in. Add local. P combo. Is that going to work? Select the local packages library product and add it as a dependency. Add other package local P combo. I don't know. That can't be right. Maybe I select the select the directory containing the package Swift file. Well, that's this one. Add package. Well, that's disappointing. Pcom preview content. All right. Select local packages product as a dependency when you order. Okay, I'm going to search for this. Well, let's see. Was this anything different? The README, the package, the source files, the targets. Yeah, we're all conforming to that. We'll configure it with the package. Okay. Add your code. Yep. Dependencies, distribute binaries. Well, we don't need to distribute binaries. Make your package cross-compatible. Build your targets and run your tests. Select a scheme for the package. Build run. Creates a scheme for each one. Select a scheme in the package. Build and run destination. Maybe that's this. Let's try this again. Select one level in and see if that helps. Select a scheme for the packages build and run destination. Select a scheme. I don't know if there's a choice for anything. Okay, let's try that. Okay, it seems to be doing something. Getting good at this part. Contain the package.swift file. Let's try one up. Okay. What did they call that thing? I don't know. Executing workspaces around. Create the app package, create the Swift package. Create the workspace. Add the app project to the workspace. Add the Swift package to the workspace too. Channel targets. Oh. Oh, well, that seems unfortunate. Build, okay, close project. Build. Click My App Project icons. Target section, frameworks, libraries, etc. Click plus. Select Add My Library. Clean build, okay. Oh, maybe I just didn't. I don't know. It doesn't show up there. That's not very encouraging. Make sure I did what they said. Select the local packages library product. I don't know what that means. Oh, clean build, okay. Let's try that. I don't think it's going to matter because I don't see it here, so I don't know why it would. Oh, is that progress? Couldn't load P-combo because it's already open from another project workspace. Okay. Where is that? Wait, what are you? Pcom packages. Oh, I've got many. Delete those. Delete that. Got too many things named Pcom, that's for sure. Okay, this is that. Oh, where's P-combo? a minute. I don't know what to think. Cancel this. Recent. Where's B combo? What just happened? Okay. Let's get a folder here. Pcom. I think pink combo was here. Maybe that package was already included and I just screwed things up. Okay, there's the package. Good. I don't know where the... I don't know where my... I guess I opened this folder. It doesn't have an Xcode workspace or Xcode project, so it's not listed here. Okay, I don't know if I just moved it in or what, but anyway, let's make something. Well, let's just make a P combo tests. D. I don't know why those are all D. All right, let's okay, let's reset. No, I think I want to keep. Yeah. Okay. Xcode. Okay, we've got P combo. Okay. So let's try this again. frameworks and libraries. Add other package dependency. Getting good at this part. Local p combo. Now I hope that's just gonna work. Okay, pcom tests. Let's name this p combo tests. And we can just take any of these tests, I think. We're not going to route these. Now I would probably need an import of some sort. Pcom. Okay, so I think I need to import pcombo. Could not find pcombo module for target. I don't know why that should be interesting. I mean, I'm running an M1. I don't know why I would care about x84. Target. So what did I do when I built this? Driver kit host. I don't know what that means. Build active architecture only. Build settings, build active architecture. Change to no for debug and release. not sure what he's saying. So I'm going to add valid arcs as a user-defined setting. Valid architectures. Well, I'm not seeing that heading. Let's try the same thing over here. Oh, this may not work. Does this have build settings? Okay. Well, that's a downgrade from... I don't know if I can get it to... No such module. Do I have to do anything to make this a module? I would think that would do it. Let me try changing this setting back. Make sure our tests do the same. Test will import p combo. And our test is a many. Public class. Public prefix function. So I would have thought that would work. Now, so what's weird to me, I import pcombo, it says it can't find it, and then somehow it's no longer concerned about these things. I'm just going to get another copy. I don't see what that's going to accomplish. This doesn't sound like Xcode. Valid arcs. Editor, add build settings. Okay, I've taken it out. It shouldn't be there. Let's add a package. I don't know if I can add a package. Let's try it this way. Add local. Combo. Okay. Well, maybe I have to quit and restart Xcode. Seems primitive. Okay. I had my hopes up. Okay. New Swift package, select main folder, add, group, do not check create, target general. This is in the app. Press the button. I don't know why I want that to be a target. Okay, file new Swift package. Assign a name to the save as. Select the main folder. Select your project in the add to drop down. Group. Do not check. Create. Okay. Models a package at the top level. And they add it there and it shows up there. Okay, target general. Target. Target. General. I think I'm coming back around to what I already have. Yep. Now this time I've got the contents and I still can't get to it. It's P combo, P combo. Well, This is so weird. Like, why writing a module it can't find, and that satisfies it that all these things are valid now. No such module. Head edited for general my target frameworks, libraries, and content to be visible to import. Now, why does that work for them and not us? um, dependencies must have dependency here. Remove import and add it again. Okay. I don't know. It doesn't sound like that's working for us. No such module. Okay. Well, this is clearly not working. I'll give it a few more minutes of research, but I'm not happy. Product scheme's new scheme. I don't see what that's going to do for us. Add to product file, add package. Well, that's what we did before. Packages. Reset package caches. I don't know why that should do anything. Build succeeded, except that it's got an error. Well, package name is pcombo. It's like everything's named pcombo. We don't depend on anything else per se. And we got to target pcombo. Now, if the code were just sitting there, it would have no problem. That's about. Well, I'm going to set this aside. All right, and where's our to-do? Okay, so, oh, I lost all that too. Packaging. Let's see, I had moved these down. 15th, 14th. Packaging. We weren't able to create a... So I think if we were to make this more bundled up and everything, that we could reference it as an online package and maybe get somewhere. The one last thing I want to try. Let's open. I know I did packages somewhere for some other product. Was it blocked? Right. There's a package dependency, basically. Like, why is that different? This is a packages folder. That's a package dependency. Can we look at anything? Well, blocked. Target blocked, general. It depends on basically like that. So, yeah, there's something in the reference for this. I don't know if it's really going to find it. I don't know. But the fact that it shows up differently is definitely a sign to me that something's funny. I don't know if this thing thinks it owns it from an editing point of view. And it might because it's all in the same big folder. Okay. Oh, have I been messing myself up with that? Let's close this one. Okay, and let's just see if, I don't know why that would have done this, but let's see if it helps anything. No. Okay. All right. Let's commit this. Failed attempt. Include combo as a package. Okay, and let's update to do. Yesterday was not the 11th. Okay. Try the library locally. Well, that's what we did. I think we'll go back to our combinators. We've dealt with that. We've dealt with that. We've dealt with many. Did we deal with many one? Open recent P combo. What the heck? To do. Yeah, somehow we have this. P combo main. Let me try a different way. Well, we definitely did many. And we did many one. We haven't done separator. We haven't done map optional bind. Dot. What was that? I don't know if that was our colon, maybe. What did we end up calling it? Maybe that was the percent thing. I'll leave that for now. Okay. What are we going to do? Well, the pipe map thing is interesting. The other one is this non-equal types goes to tuple. I think that's probably the most important one we have at this point. Okay. So the way we are now is if you have two equal types, we put them in an array. And we also need to deal with array plus the match of the contents. We want to build up arrays. If you have A and B and C, we'd like an array of three things. And then we have these left and right only ones, which are kind of handy for some things too. But I think of the combinators we could do, the ampersand being kind of incomplete is the worst problem. So let's tackle that. And I think we'll take a break. I'm not sure how long I'll go today, but probably an hour, maybe an hour and a half. So a 3-minute break. We'll come back and go back to working on combinators. And I'll do something offline to see if I can figure out the problem we had with packaging. An hour of pain is enough of that. All right, so see you in about 3 minutes. Hi, welcome back. Okay, let's look at the and then. I think actually looking at the class would be the best. All right, so we have and then array. If you have two parsers of the same input type and same target type, so same type of parser, then we say we're going to create an array of those two values. And the ampersand operator knows that case. Okay. What we want to do in this case, we want an and then that's a tuple if the two types are not equal. And then we're going to return a tuple of P1 target and P2 target. Okay. So let's define that. I'm trying to think how to make them different types. Well, maybe we need to do pipe first. Let's do that. We have a notion of a pipe operator, and we did that in our playground too. Let's see. Okay. So the notion of a pipe is we would like to take a parser and then a map function that turns your target type into a new type. Okay, so imagine we match an integer. Well, let's match a character 9, the digit 9 character, and we'd like to turn it into the integer 9. Okay, this map function would take the character and turn it into an int. And then when you applied it to things, you'd have a parser the bigger parser that takes characters as input and produces integers as output. Okay. And I mean, I don't think we're too far off here. I might just do the one side though. But this oh yeah, here we have an example. Okay. Pipe digit, the digit parser matches the string 9, and we do a conversion function that turns it to an integer. And if you parse array 9, okay, so character string 9, then it will convert it. Okay, so let's I hope we can see this line still. Are you running? Okay. Yeah. Okay. So digit as int dot 0. Now why is it? Oh, because it prints it. Okay. So you can't really quite see the type, but let's see what that tells us anything. Okay. So it produces optional int. Okay. At any rate, I think let's do that as our goal here. Okay, so, and I don't know if pipe, I want to call it map, but that's so overloaded. um, you have the functional map operations, and you have map in the sense of a dictionary. But we'll use the word pipe. I think again that's probably more from the functional language end of things. They tend to call it pipe. Kind of is analogous to Unix pipes. Pipe tests. Okay. And it's going to look like any other test. It needs this stuff. Okay. So, what would we do? I just want to change domains somewhere so I can see something happening. Let's see if it took a number and turned that into a character. Okay. Yeah, let's do that. We'll take a simple case. Okay. Test convert int to character. Okay. And so we'll make a parser sat1 equals satisfy 0 equals 2. Do we care? Let's take any integer instead. Let's just return true. Okay, so this parser matches one integer. Let pipe equal pipe, and then we're going to give it a parser, and we're going to give it a function. Let's return ABC at that. I'll make it ABCDE just to be a little bigger. Okay, so my idea is I'm going to take whatever value I get from sat1 and use it as an index into this array. Okay, and if we do result equals pipe dot parse of array 1 0 3. Alright, pass to call takes no arguments. Well, it does not write pipe yet, so that's the way it goes. Okay, and then at the end, check success. The actual, well, that's result. And the expected, I think we're going to get B with the expected remaining 0, 3. Okay, now pipe. Well, let's define it here. Pipe is a parser. It's generic over parser type and value. Okay. P, and I'll just say value. Okay. And then we should have some associated types. Yes. Okay. The input type is P's input. Okay. The target, it's a little trickier. Oh, target is V. The target type is value. So you give us an input of type input, and we're going to produce a result of type value. And then this map function is just a little helper. We'll borrow that. Okay, so these two are the ones that are required, and hopefully it just wants a parse function. No, I don't know why it's not recognizing those. Okay, target p.input. Well, we've got a different setup than this thing had. Okay. Expected member name. This should just be target. Actually, it should be input. Var? No. Type alias. Okay. So our original target, like our input parser that's int, yeah, this is what we want. Our original parser is int in our test, and its target, the new target type, is character. Okay, and so we need a function that goes from int, the target of this parser, to value, character. So give us array input p.input, and we'll produce a parse result of p.input. Yes. Maybe. Input is p.input. Yes, and the target value. Okay. So we'll create a new parser that is ints. Give me ints for input. I'll give you values for output. Okay. And then for now, let's just return a failure. We're just trying to get enough there to make this. Could not be inferred. Yeah, I got to do that. So the input is, well, let's say the parser type is one, satisfy. And the target is character. Argument passed to call it. No, that's not right. Pipe. Well, we want to give it an initializer. We don't have one. Okay, I guess that part's legit. Public init takes a parser of type P and a map function. parameter uses an internal type. Maybe we can just let that be. That's not so bad, is it? Okay. How are you doing down here now? Cannot convert value of type satisfy void to satisfy any. Cannot convert value any dot target. Insert as string dot index. Okay, well this one might be legit. I don't know how to. I guess I could say array of characters sub $0. Okay, but this satisfy. Okay, we got satisfy somewhere here. I guess satisfy int in our case. Sat1 is satisfy int. Okay, well, we're there. Cannot test target, must run on a concrete device, yes. Should fail if there's any doubt in your mind. Okay, we got back the hard-coded failure. At least we're calling the right function. Okay, so the deal is, let's see. We need to store this for sure. Okay, so let's do let parser of type P and mapper of type P.target goes to value. And we need to say self.parser equals parser. Self.mapper equals mapper. Okay, so we got to store those things. Oh, I always leave out those. Okay. Good. Okay. Now, we have a parser, we have a member. All right, I'll take a peek at our earlier result because it's pretty good, I think. Okay, we got to parse, get our result, and we were our prototype. We used nil as a return value to indicate a failure. This one is not, so we need to tear it apart, but we can do that. So let result equal parser.parse of input. Okay, and then if cannot be used, that is a return. Okay, we parse our input. I think let's just say it fails. If case failure of location and remaining is result. Okay, so if it failed, then we need to change it to the return type for this parser, which is slightly different. Okay. So if the original parse failed, then we're going to return failure, location, and sorry, this is message and message. These two types have different domains. So this failure is the parser P1 failure. This failure is our failure. And our type is more complicated than P because we take into account the value. All right. That tells me it probably would have been a better test. Let's make another test. Whoops. Test pipe on failed parser returns failure. Okay, so let's make one that always fails and do what you want. Okay, so we got this mapping function. We do this should be a failure. We need the actual, we need the expected. Let's see this method. Oh, okay, and expected, yes. Check failure, result. Well, what we expect is a failure at position 0, and the message is just the default message. Well, let's make that explicit then. The message, and let's put it in here. So we made our sat parser accept a parameter that is the message it will return. Okay, that's junk. Okay. And let's go back. Well, let's put this case here. Okay, so I'm skipping forward to the failing test first because I kind of need to check that one way or the other. I hope that was just a breakpoint. Okay, so pipe test. So we didn't get the right message. We didn't get the right thing, of course. Let's take this out and put this back. So failure message, we think this should be okay. They're old messages. We'll run these. Okay, good. Even though this is the happy path, I think it was just easier to make sure the sad path worked first. Okay, this test should fail. Get back 100 this. Okay. Yep. All right. So now we've dealt with the failure. So let's make this a switch. We only have two possibilities. Success. Oh, what do we get? We get a value and a remaining. Okay. And then this we don't need because we never get down there because we're covering everything. So we succeed. So what we want to do is return a success. We want to apply the mapper to our value, and we want to get the remaining. Okay, so we'll pull out, the parser will give us a 1. We'll run it through this thing. We should get a B from this function, and then the rest of the input is still 0, 3. Okay, and let's run. All right. That is good. And it's pretty simple. Yeah, okay. And then one more thing we want to do is have an operator that does this. So it'll be somewhat like this. This should probably be pipe convert. Pipe operator. Okay, and in this case, it should become much easier to write. We should be able to say sat1, and we'll use this pipe to that. Is that the right? Let's see, what do we do here? Oh, we gave it risk greater. Well, we're gonna use this same mechanism. So let's right, consecutive statements. There's an issue there because it doesn't know this operator. Cannot find operator in scope. Okay. I think I'm gonna keep that word. Okay, so we're just gonna make it like this. Multiplication precedence, so it's comfortable going at the end of a series of stuff. And this p parser via value, parser escaping this to that. Okay. P to fn. I don't know. I can make it. Let's do this. No conversion. I think it'll fail to build. Right. Yeah. So, I don't think there's a choice on this. P function. Yeah. I think that's just kind of the way it's going to be. And so this should just pass. All right. Let's commit these. This is added pipe operator. All right, and then we certainly need to put into its own thing. Okay. All tests should pass. So much for that theory. Cannot specialize a non-generic definition. Is he getting the right pipe? Let's clean the build. I'm going to call it pipeline. Oh, I'm getting my... We'll change the name for now. I just think it's going to the wrong place. Let's see. How do we get the reference right? I think, gosh, Swift is adding something for this. Oh, that's it. Yeah, import. Oh. Directly import their model, it'll override the result. You can still use a qualified name. Yeah, I don't want to. I thought there was an import as or something. All these languages add their stuff. Let's find the Swift. I don't care about those things. Swift language guide. That's more like it. And this drives me crazy. I don't have a search here. Lexical structure, statements, declarations. How about an index? I just can't believe they don't have a search for this thing. Okay, I don't want to get stuck on this forever. Let's just make it explicit. Random tests, okay. It's so fast, it's hard for me to believe. I really don't want to see the diffs, but I seem to be in that mode. Okay. And then test, pipe. Okay. Extract pipe to separate file. And then finally our documentation. This is a combinator. And it looks like this. Oops. It has high, I'm going to say multiplication precedence. And maybe I need to use that language up here too. I got this mode of automatic diffs. Okay, sequence, prefix. Low is addition precedence. So you can see now where I had my sequence of non-matching types, which is still in my to-do list, right? Well, that's what we want to do now, so it'll be fine. Did that not take? That's weird. Okay. Some update issue. There it goes. Okay. All right. Let's deal with and then again. Okay. So and then tests. Okay. And this, let's steal this. Okay. So 1, then 2. We're going to modify it. We're going to pipe it to a function. Right. We'll get there. I want to convert my integer to literally anything else. Maybe float's good enough. I don't know. Will that get confusing? Okay, so given my integer, this... Oh. I thought I could do that. Well, that should do it. Cannot be applied to int and double. Really? Okay. Forgive my ignorance. Swift convert int to double. I thought I just called the double constructor. Yeah. Maybe the exclamation point was redundant. That looks like annoying. Okay, yeah, this is more like it. The result type should be 1, 2.0, and it should be a tuple. Okay, we're really messing up things. And double cannot conform to equatable. Oh, really? Oh, come on. Alrighty. Let's see. So int double cannot conform to equatable. Let's try let's try this. Int can conform to equatable. No, I thought there was a move to give you equatable in tuples. All right, let's make an enum instead. Enum wrap case int of int. Okay, so I'm just going to wrap it in this type. And wrap.int of $0. Conflicting arguments satisfy int. Oh, that's even better, isn't it? So it, instead of just saying ambiguous, it says satisfy int versus satisfy int wrap. Okay. And maybe our result type is not. Yeah, but that's okay. I think that's an improvement. And this should be. Oh shoot. Maybe check success is going to have another version. I'm going to say int wrap cannot. Okay, maybe I should just break apart check success because it's just a little weird. Oops, I want AndThens. Okay, first we check that it actually that it was a success and not a failure. And then target okay, target.0 should be 1. Oops. Target.1 should be rev.int of 2. And remaining should be 5. Let's take this wrap out. Let's make it back to double. Okay. Fine. 2.0. Okay. So you reference the two parts of a tuple as 0 and 1, since it's got two items, 0 and 1. Sorry, two items expected here. Okay. as a result is ambiguous because parser is ambiguous. Okay, I think we got a valid starting point. Okay, now where's our and then? Well, and then is just going to be similar. Well, maybe I do this. And I'm going to call it and then tuple just to distinguish them. So we have P1 of parser, P2 of parser, and we're a subtype of parser. Okay. Input equals P1 dot, oh, we need to qualify it. I always forget where to do that. It's here, I think. Where P1 dot input equals P2 dot input. They have to be parsing the same kind of things. And yeah, equals. Okay. And expected something in class. Okay. P parser is P1 of input, and the result is a tuple. P1 dot target, P2 dot target. We're not going to need this for a minute. Okay. Expected brackets in class. I'm obviously forgetting something. Attribute public can only be used in a non-local scope. Cannot find P1 in scope. All right. Who else does a where? Or else? Oh, it comes after the thing. Okay. P1, P2 parsers, results parser where the input types are the same. The output type is now a tuple. And the contents, well, they're kind of irrelevant. Since we're just going to return a failure. Okay. And then we need P1 parser, P2 parser, parser P1 of P1, parser P2 of P2 returns, and then tuple, and then tuple, parser P1, P2, specialized with too few parameters. Oh, tuple P1, P2. Okay. Oh, I commented too much. Okay. We'll need the init. But we won't need that stuff yet. Okay. Whoops. P1. P2. Okay, I think that's good enough to get us to a failing test. Good, it compiles. Okay, we got one message. Yeah, so that's something. All right. Now let's hold our parsers because we're going to use them. Okay. Result equals parser1.parse. Yes, that's a good start. And if result 1 is success, let's see, result 2 will parse result 2. Okay. So we parse result 1, parse result 2, starting where it left off. If case 2 is a success, then we're going to return a tuple with remaining 2. Otherwise, a failure. Let's put an arbitrary failure in here just to make clear that we haven't tested it. Okay. And case failure. Be declared. Oops. Okay, good. All right. And I don't think we need that one at all, but we'll keep it for now. Okay, so I think we've got the happy path going through here and here to a success, and this test should be fine with that. No. And then, oh, geez. B1, B2. Okay. And then do I need to check the other cases? Yeah, I guess I do. They're going to be very similar to this, but we'll check them. And maybe I can call check failure for this one. Let's see, result is a parse result with a pair. I think we're maybe doing something a little funny. I don't know. Okay. Result is not used. Parse result check. His type is wrong. Yeah, I don't know. I feel like I could do a better job on these helper methods and maybe get more use out of them. But we'll inline this assertions for now. Failure location 1 equals actual. And then well, what we expect is failure. Well, we don't need to create the thing. We can simplify this. Okay. Expected failure, but got something else. Okay. So the location we expect to be 0. and the message M1 or M2, we expect M1. Okay, so the very first thing did, well, okay, so we expected 1, 2, 1 followed by 2, and when we don't see the 1, we expect to get the message M1. Okay, and this test should fail with 99, no, 90, 98, whatever we did. 999, yeah, the second one. Okay, so, and then this one becomes real. Never be executed. Okay, yes, we thought that was the case. And run that test again, should pass. All right, and we'll do an analogous one. And then fails if second parser fails. Oh, and this should be and then tuple. All right, second parser fails, M1, M2. So this should succeed. 1, this one fails because it sees that. So failure location message. I think we'll do the same here. Location message. Okay. Down here, we expect the location to now be 1 because it got past the first item, and the message should be 2. It should fail because we haven't prepared it yet. Let's run all tests. Yeah. Good. All right, so second parser fails. All right. So we have, let's see, it's in the same file. I'm pulling down the operators down to the bottom because they're all going to be kind of a jumble. I mean, there's going to be a lot of variations. This one is P1, P2, parser 1, parser 2 are the same type. And this next one is they're different types, so they produce tuples. We need more of them for all the variations of AndThen, unfortunately. But this worked, so I'm happy about that. Provide AndThen Okay, so we can have parsers dealing with incompatible things. And especially as we start using more pipes and trying to convert, I mean, the goal of parsing is not usually just like, oh, prove you can parse it, match this thing. Usually we've got some information we want to capture along the way, like a compiler wants to convert your input into a tree of some sort. And these pipe operators are what are going to help you do that. All right. I think this is a good place to stop. So let me remind you again, if I didn't already, I'm out next week. Last week of July, no sessions. August 1st, I should be back. And we will pick up there at that point. So let's commit this. Okay, that's done. All right. So we'll take care of this, these other ampersand operators and the recursive one and whatever else we need to do. We're getting close, and I will do a little research and see if I can figure out what's going on with that packaging issue, and maybe I'll go ahead and put the GitHub package up there. It's just so it's an independent thing. I think that'll work better. All right. Thanks for joining me today, and I hope to see you again in a week or more. Take care. Bye-bye.